Alright, so let's finish this off. Now we've set up our basic cloth and particle system, so we've got our cloth giving us the basic structure here, the elastic behavior, the swinging behavior, and we've got our particles that ultimately will be rendered. Now what I want to do now is I want to add the sort of the teardrop shape to my particles. Right now you can see they're just in a perfectly straight line. And I also want to add the ability for the ends of this, the particles to come flying off, to get released when I want them to be. Alright, so let's set that up. Now if we take a look at the expression editor, we can see that right now the runtime expression, pretty straightforward. All it's really doing is it's driving the particles forward in the u direction of the surface. So what I want to do now is I want to, I'm going to go step by step, but first thing I want to do is I want particles to die when they get past a certain point in the u direction of the surface. If we take a look at something here, here's our particles. If we let this run and check our particle count, and you can actually even see this as we go, you can see that the particles start to accumulate down at the bottom. Now because their incompressibility is so low, we can pack a lot of particles into one little spot, but it's not really a good idea to do that. So we can see that our particle count just keeps going up and up and up, and it'll go up forever because these particles are never, they're never dying, because our lifespan is set to lifespan pp only, and I haven't defined their lifespan, so they'll just go and go and go. Alright, so particle expression. So what I want to do is I want to add this section to it. If the goal u is greater than or equal to, and in this case I'm going to say 0.99. Remember, our surface goes from 0 to 1, so this is pretty much the very end of the surface. So if our particles get past the very end of the surface, I want to set their lifespan pp to 0. I've got an extra little line of code in here that's commented out right now. It won't do anything just yet, but what it does is it turns off the goal weight per particle, so my particles would just slide off the surface. So let's pop that into our expression. I'm just going to grab this part. This stuff is already in there. Edit. Alright, so now if we play and watch our particle count, particles get down to the end and they start to die. So right now our count is 94. Let it play. 98. There's going to be some variance in there, but it's always going to hover around 90, at least in this case with the, the rate set the way it is. But we can see that, yeah, our particle count is not going up significantly. Good stuff. Alright, now, just for fun, I shouldn't have rewound that. Let's try the other one. Instead of killing them, let's try, let me comment this out so that's not working. Get rid of those comments. There we go. Now, when I run this, now my particles, when they get to that point, or when they get past 0.99 in the u direction, their goal pp value will be set to 0, and so now they come off. So now, we're very much getting that, dog drooling, the slathers just coming out effect. This is more than I would want. We don't have any real control with this. If you had a dog that was just drooling perpetually, you could do this, but we can add some control to that. It's kind of fun to watch all that slobber flying all over the place. Alright. So far so good. Alright, now, like I said, one of the things I want to be able to do is control this, and right now we don't have a ton of control over that. So let's add some control. Alright, so I'm going to select the locator, and right now we can see the extra attributes we've added to it. We've stretched, had them forever, rate, and forward. So now I'm going to add a release attribute. Modify attribute, release. This is going to be an integer because it's only going to have two values, 0 and 1. I'm going to set the default value to 0. The minimum will be 0, the maximum will be 1. We're just turning this value on and off, so we'll say OK. Alright, there we go. So there's my release attribute. Now let's take a look at the next expression. Alright, so for my next expression, we're going to incorporate this. So, just like we did with forward, I want to take the value of my release attribute on my drill control. I want to put that into a variable, and then I want to use that variable. So I want to say, okay, if release doesn't equal 0, set the goal PP to 0, and set the lifespan PP to 500. I want my particles, when they go flying off, I want them to live a long time. And then this is the same one we already set up. I took out the goal PP part of this part because it doesn't really fit in here. Alright, so let's just replace that whole thing. Expression editor. Alright, so maybe make this a little smaller now. It's maybe a little too small. Alright, so there we are. So now I've got my expression. So now we're, like I saw, we get our release value. We use that in our expression. We set the goal PP and lifespan. Alright, edit that. Cool. Now, right now our release is set to 0, so they will never release, so we need to animate that. So, let's see. Alright, I just paused there for a second to load up a play blast. So this is our simulation so far. We've got our particles coming down, they die when they get to the end, and then around frame 260 the dog turns its head. Alright, so now in this case, for the release of the drool, I'm actually going to keyframe animate that. Now I mentioned before, with something like this you could set it up to release against whatever criteria you want, velocity, age, whatever. In this case I'm going to keep it simple, and I'm just going to assume that animators want very specific artistic control over this, and I'm just going to keyframe the release attribute. So just to see it simply, I figure I'll set a release early on, say around frame 79, and then when the dog turns its head, say around there we get that sort of whiplash effect, say around frame 270, 272. Then we come over here, same thing on this side, about 312. Yeah, I think that'll work. Alright, so back. Alright, so here's my locator. There's my release attribute. So I'm going to middle mouse button, advance to frame 79, and set a key for release. Go to frame 80, turn release on. So whenever the release value is set to 1, it's going to be releasing the particles within that range. And I'll advance a couple of frames. I like to advance a couple of frames before I turn it off. Key selected. I'll do the same thing up here around 272. Key that off. Advance 273. Turn it on. So we get our release. Now keep in mind, as I do this, particles have built up within that range, and let's say, go an extra frame there, 276, turn that off. So when it releases, there's a bunch of particles in there. Key selected, and then 312. Key selected, 313. Turn it on. And 316. Alright. Pick my particle. Let's play that again. Oh, hang on. I think all my particles released there. Okay, so let's check our expression. Expression editor. All right. Okay, yeah. So what I'm saying here is, okay, if the release does not equal 0, goal PP equals 0. Great. So when the release value is set to 1, my particles release. And that's exactly what's happened. All the particles released on here. But I need to have a little bit more control over that. So let's take a look here. So yeah, we're saying if release equals that, or doesn't equal 1 or 0, release all the particles. So we need to have a little bit more control over this. So if we look at this next one, you see that I've modified the expression and I'm saying, okay, if release doesn't equal 0 and if the goal U value that the particle has achieved so far is greater than 0.8, then we do our release. Nice thing about this is it'll only release particles within this range around here. Now obviously I can set that to whatever value I want, and you could even include this in a control attribute in your drill control object. In this case I'm just going to go with this. But yeah, absolutely, you could set this up as a control that you can change. Alright, so let's go to our expression editor. And I'll just swap all that out again. So yeah, now we've got our release if release doesn't equal 0 and our particles are within that particular range of the surface. Alright, so let's play that now. Oh, got a little weirdness because I started and stopped. I wouldn't worry about that. So now around frame 272 those particles should release, but only at the end. There we go, very nice. Then we come over here and those particles release off the end. Cool, looking good. Alright, very nice. Okay. So yeah, that's looking pretty good. Let me just check my expression here. Do we have everything in there that we want? Yep, creation expression hasn't changed. We've got everything from our runtime expression. Yeah, looking good. Oh, one other thing. I've already included this in the expression, but at the end, when the particles die, I've also modified this so I say, okay, if we get to the goal U value of 0.99 and their goal PP value doesn't equal 0, we set their lifespan to 0. If we don't do that, if we don't have this section in here, what happens is the particles that get released, their goal U value keeps going up, and so they end up dying, which we don't want. Once they get released, we want them to live for as long as, well, as long as we want. Alright, so that's pretty good. Alright, so what I want now, but the last step, is I want to work on the shape of this particle system. Right now, as you can see, they're, you know, perfectly straight, which is kind of boring. Alright, now there's different ways I could do this. I'm going to take advantage of the ability to drive the radius PP, or the radius on a per particle basis, with a ramp. So first thing I'm going to do is I'm going to add the radius PP attribute. Radius PP, there we are. Add that. Radius PP, where are you? Gotta reselect so the screen refreshes. There we are, radius PP. Alright, so I'm going to right mouse button click on this and go to create ramp. And I'm going to open the option window. This is awesome. This is really great. Alright, so even though we're dealing with a surface's U direction, that doesn't really matter because the ramp that's going to get created is going to be a V ramp. I could use the U ramp or the U input if I wanted and just change the ramp to a U ramp, but I don't really need to. It's arbitrary anyways. So I'm just going to stick with the default input V. But instead of particles age, I want to drive the particles with their goal U. So I select that. Alright, now I'll click OK, which will create a new ramp. So there we are. So now what's happened is, and you can already see what's happening. Alright, so let's take a look here. So if I right mouse button, click again, go and select Edit Ramp, we can see this is the ramp that Maya is using to drive my particles. So what's happening now is when the particles are born at 0, or 0 in terms of their goal U value, they've got a value of 1. And then as they get to, or as they get to 1 in terms of the goal U value, their radius PP goes down to 0, and we can see that happening here. So they're born, or when they're at goal U0, their radius PP is 1, and as they get to goal U1, their radius PP goes down to 0, which is kind of neat. Not really what we want. Almost what we want, but not quite what we want. So what I want is more control. So what I'm going to do, or what I want is to precisely control the shape here. So what I'm going to do is I'm going to go to my color at position 0, and I'm just going to change this value. I'm going to change it from 1 to 0.05. And obviously, you know, experiment with these, use whatever values work in your situation. The middle one, I'm going to make this quite small. I'm going to set that to 0.03. See, change there. And then the last one, so down at the end of the surface, I want their radius to be quite large, 0.125. And if I advance a frame, there we go. So now we can see our particles. So now we definitely get nice results where as the particles are born, they're fairly fat, they get skinny, and then they get fat again. Actually, let's nudge that up a little bit. Instead of 0.125, let's try 0.15. Okay, that's pretty good. Now our rate right now isn't very high, so you know we're seeing lots of gaps there. So let's try turning our rate up from 100 to 1,000, and now this is going to be a little slower. So I'm just going to pause the video and load up a play blast. All right, so here's a play blast for my simulation so far. So we see our drool comes down. We get that nice teardrop effect as the dog moves its head side to side. There we go. As it moves it side to side, we get that nice whiplash. The particles come off. It's nice and disgusting. It's looking pretty good. Now there's still a couple of little things to deal with. One is, now you notice that what's happening now when my particles release, we can see that clearly my particles are keeping their size as they release, which is kind of nice. You know, this doesn't look like particles releasing, it just looks like the end of the stream coming off. But we can see what happens here is as they release, my particles' radius PP changes. What's happening there is, if you remember, the radius PP is being driven by a ramp that refers to the U-goal value. Let's look at our expression. Remember? So our U-goal value keeps going up and up, right? Here's our runtime expression. So our U-goal value keeps going up and up based on the forward value. So what's happening is once that U-goal value goes beyond 1, in terms of the ramp, here, let's go back to our ramp. In terms of the ramp, what happens is they're wrapping around. Let's look at our ramp. So what happens is, as our U-goal value goes from 0, builds up and up and up, once it gets to over 1, it starts wrapping around again. It goes back to 0. So we get our particles looking small again. So what we want to do is be a little bit more precise in our control of that. So what I'm going to do is, instead of just building our U-goal value, this is currently what we're doing, what I'm going to do is I'm going to include this, what we already have, I'm going to include it in an if statement as well. So I'm going to say if the goal PP doesn't equal 0, in other words, as long as my particles are holding onto the surface, I want their goal U value to go up. But as soon as they release, and that's what we set up here when we release, we set that goal PP to 0. As soon as our particles release, I don't want that goal U value going up anymore. So they'll hold their size. So let's just grab this section and pop that into our expression. Pop that in there. Edit. Here's our old play blast with our guys getting small. And let me just load up a new play blast. Alright, so I've loaded up my play blast, so let's take a look at our simulation now. Alright, see our particles come down, we see the teardrop form, and then when the particles release from the end, we see that they hold their size, which you know, is pretty crucial to the effect. And that looks pretty good. Cool. Now, a couple of little things, and again, this is now just part of, you know, tweaking the values in a dynamic simulation. You know, when my particles come off there, in this case, you know, they really fly off a bit. I could either increase the viscosity even more on these particles, but I'm actually, I kind of like this behavior. I don't think this is too bad. So I could increase the viscosity, or I could start using force fields in the particles to hold them together. I find with stuff like this, though, with force fields, you have to be very, very delicate with the values, or that your particles really start to clump up, which I don't like. Now, one other little thing. You notice up in this section here, and throughout, see we have these weird little sort of popping particles. This is a strange sort of effect that you get with end particles. If you were to set up this exact system with the old school particles, you wouldn't get this. It seems to have something to do with how Maya deals with the connections. As soon as you have an expression relating to the radius pp and this the radius pp being driven by an outside connection like a ramp, you start getting these miscalculations, which is kind of annoying. The good thing is, if you cache these particles, they don't show up. So it looks like it's just some kind of weird display miscalculation. So yeah, caching it just solves that problem. And since you're going to cache this anyways, then it's not really your problem. Now, one little thing, you notice how right here, as we're getting a very extreme dog movement, the particles are passing through the surface. That's not actually a cloth problem. That's my particles. Right now, the goal weight for the particles is 0.5. So what's happening is, as my cloth moves around very violently, the particles are actually coming off the cloth. So to fix that, I would just crank up my goal weight. If we take a look, see my goal weight is 0.5. If I you know, crank that up, if I crank that up all the way to 1, then you know, my particles will stay on the surface much more precisely, well, with complete precision. So we shouldn't get that effect. The nice thing, though, about having a lower value is it does give a little bit of randomness to the particle position, which can actually look nice. So you know, you can adjust that attribute as you need to. So yeah, so that's looking pretty good. Now, actually, let me just let that run a little bit, and oh yeah, let it run a little bit, and maybe we'll just do a render of that. See what these guys look like in their nicely splayed out, messy mode. Chug, chug, chug. You can see with still creeping through a bit there. I might have to recalculate the cloth a little bit. Alright, let's move in there, and let's see what this looks like in a render. I'm just going to import some lights. Lights. Draw lights. Alright, so I got some lights in there, and render globals, rendering. Or, I guess I don't have to go there. Render settings. So obviously you can render this however you like to. I'm going to render it with mental ray. Make sure that ray tracing is turned on, so we get nice refraction. There's already a nice water material assigned to these guys. That's part of setting the water preset. I have to turn this up. Production motion blur. I want motion blur on those particles. And let's see, select the camera. I'm just going to put a little bit of a bring up the background color just a little bit. Yeah, let's try that. And let's just do a render there, see what it looks like. My render size is a little high, well, high based on compared to my screen resolution. Well, I think they're the same. Oh, my surfaces are still rendering. I want to turn off the render of my surfaces. I can still see the ramp color in there. But this is not looking too bad, that aside. Yeah, definitely do want to see the cloth when you render this. So, yeah, not looking too bad. Obviously, you know, a whole rendered sequence is going to look, you know, more fun than just a still, but that's not too bad. Alright, so that's what that looks like. Yeah, not too bad. Maybe I'll just store that for a second. Alright, so that's not too bad. Okay, so last thing, well, not the last thing, but if we, you know, if we take a look at, if we select our particles, a couple of things that we might want to adjust. The blobby surface threshold. Oh, that actually wasn't too bad. So, yeah, that wasn't too bad. So yeah, I think the key thing now is caching this stuff. We can come back to adjusting particle attributes in a minute. Alright, so yeah, so I want to cache this all now. So here are my extruded surfaces, my cloth surfaces. Remember, these are the original cloth surfaces. This is just a surface that I combined for that. So I'll select these guys and dynamics and cache. So I'm going to cache these guys. Create a new cache. And the options that you choose regarding creating your caches, well, they'll depend, you know, more on your pipeline requirements. I'm going to go with 1 file per frame. Make sure that it's set to time slider, and click create. Oh, hang on. Oh, your file. Oh, I see. It's because I've selected the transform node. Well, let's just try picking this guy. Alright. Yeah, this should work. I mean, it does have the end-cloth connection to it. That's one thing when you're dealing with proceduralism in Maya, keeping track of where you are in the history. So picking this guy should work, and if I want, I can be extra sure by selecting the end-cloth shape node here in the attribute editor. And so let's try that again. End cache, create new cache. 1 file per frame, time slider, evaluate every frame. This should be good. Alright, there we go. Just takes a minute to create the cache for the cloth. Now, remember, right now I'm only creating the cache for the cloth. And you can cache the cloth at any point in the process that you want. I like to leave it kind of to the end, because the end particles actually affect the end cloth, so it's kind of nice to get that interaction. But if it's simpler for you to just set up the system, get your end cloth behavior the way you want it, and then cache that out, and then just add the particles as a sort of the cherry on the top, that's perfectly fine. Alright, so I've run the cache for my end cloth, which is nice. So at this point I really shouldn't see much difference in the simulation. It should all look pretty much the same. But my end cloth is cached out, and now I'm going to do the same thing for my particle. So I select my particle, create new cache, all the same choices as before. Click create. Alright, so I've cached out my particles, so a nice thing about that is now I can scrub through here anywhere I want. See my particles doing what they're doing. Quite like that action, that looks nice. So yeah, pretty much ready to render. Now actually one thing I almost forgot to mention. Before you cache the particles, but after you cache your cloth, now you remember with my, my particles, let's look at collisions. I turned off collide for my particles because they were colliding with the end cloth, which was, you know, causing problems. Once you cache your end cloth, you can turn collide back on for your particles, and then you can have your particles collide with stuff. So if you need to have your particles, you know, hitting something like the dog, or you know, hitting the ground or a wall or a dinner guest, then yeah, just turn on collide once you've cached your end cloth, but before you cache your particles, and then you're good. And then one last little thing I mentioned before is adjusting the look of the particle itself. Under shading, right now I'm using the blobby surface particle type. That's the default for water. Adjusting the threshold value will adjust how much your particles sort of smooth together. I'm going to increase that to 1. Because right now we can see that they're doing a pretty good job. We don't really see too much of the individual particles, but increasing the threshold will help smooth that out. And oh, just a couple little things. My poly surface here, as you can see, I definitely don't want that to render. So let's see, poly surface shape, render stats. So let's just turn everything off. I definitely don't want to see this guy, or I could just make him invisible. And yeah, we should be good to go there. So yeah, at that point you're just good to set up a render. So let's see. Let me just double check this stuff. Same thing with the collision geometry. You definitely don't want the collision geometry rendering. I've turned that off for all these guys. That's good. Yep, that's good. So so yeah, I think we're in good shape to render. So now that I've got my cache, switch back to camera, and I think I'll save this now. Save scene as. Jewel 4. Final. And then I'll just set this off for render. So I hope that was helpful. Like I said, the idea here was to create a workable, well, controllable, relatively easy to set up dynamic drill system with end cloth and end particles. So yeah, so I hope that was good for you. Thank you.